Okay, let's see more examples of power series that we want to find the interval of convergence and the radius of convergence. So the next example is this power series sigma of -1 to the power of k, x to the power of k over 6 to the power of k, as k runs from 0 to infinity. This is a power series, and we need to answer two questions. One is, what is the interval of convergence? And also in this regard, what is the radius of convergence? So for the interval of convergence, I want to write it inside this box, and also the radius of convergence. In fact, I want to know that what is also R. So let's apply the root test as we saw in the um, previous examples. So if the limit of the kth root of absolute value of the general term of this power series, which is -1 to the power of k, x to the power of k, 6 to the power of k, the limit of this, if when k tends to infinity, if this happens to be less than 1, for sure the series is convergent. So first of all, when we apply the absolute value, that -1 to the power of k disappears because absolute value makes everything positive. So we don't see that -1 to the power of k. So we'll have the limit as k tends to infinity of the kth root of absolute value of x raised to the power of k. 6 doesn't need absolute value because 6 is already positive. 6 to the power of k. So the kth root of this fraction, obviously using basic algebra, this index k and these two powers of k, they cancel out. And we want this to be less than 1 to guarantee that the power series is convergent. Therefore, what's left over is absolute value of x over k, I'm sorry, over 6, sorry. Absolute value of x over 6 must be less than 1. There is no need to the limit sign because there is no k there. That limit is for k tending to infinity. No k is remaining, so there is no need to the limit sign. So if I multiply both sides by 6, absolute value of x is less than 6. This means that x is between -6 and +6. X cannot be equal to these two because if you replace x by -6 and 6 in the original problem on the top, you will see that you can easily see that the general term, the limit of the general term doesn't tend to 0, so you don't get a convergent series. So -6 and 6 are not included. So the interval of convergence is going to be the open interval from -6 to +6. The radius of convergence is obviously 6 because the center of this interval is 0, and 0 is 6 units away from the endpoints of this open interval. Let's see another example. The next example is a little bit tricky. I have a sigma of 5kx to the power of k. In the previous example, uh, we didn't have this situation that we have a factor of k multiplied by x. As k runs from 1 to infinity. This is a power series. And again, I have two questions. One is the interval of convergence. And two, the radius of convergence. Again, let's apply the root test. So the limit as k tends to infinity of the kth root of absolute value of 5kx to the power of k. If this happens to be less than 1, it guarantees that the power series is convergent. For the x's that satisfy this inequality, for sure the power series is convergent. If it is more than 1, it is definitely divergent. Okay, but let's see for which x's this is going to be less than 1. First of all, I can get rid of this power k here and this power k here. I still need the limit sign because there is one k remaining, and that is in the absolute value of 5kx. Five k is a positive number. Let me pull it out of the absolute value. So just keep absolute value with x. So here k tends to infinity. So this 5k is infinity. If absolute value of x is anything other than 0, when infinity multiplied by that will be infinity, cannot be less than 1. Again, if x is anything except 0, for instance, suppose x is 1/2, then when k tends to infinity, 5k is infinity, and infinity times 1/2 is infinity, is more than 1. So the only time or the only number which makes this inequality be true is when x is 0. So in fact, the interval is just 1 point. In the previous examples, we didn't have this situation. But here, the only x that makes this happen is x equals 0. In the previous examples, the interval was an open interval, but here is just 1 point. So if I want to write down the interval, it is the set of only x equals 0. X that only x could be 0. It's not an open interval. And the radius of convergent is 0. The reason that this happened is because inside these parentheses, a k next to x happened here. Okay, let's see another example. Consider this series x to the power. In many of the examples, x was raised to the power of k, but let's make it to something else, like 2k plus 3 over 5 to the power of k minus 1. And k runs from 1 to infinity. Again, two questions, the interval of convergence and the radius of convergence. So the interval of convergence and the radius of convergence. As usual, please try this on your own first before watching the video or watching the solution. You can pause the video and try on your own. Again, let's apply the root test. So I want the limits as k tends to infinity of the kth root of absolute value of x to the power of 2k plus 3 over 5 to the power of k minus 1 to be less than 1. If this happens, for sure, we know that the power series is convergent. We want to know that for which x's this is going to happen. First of all, if I apply that absolute value, the only thing that needs that absolute value is x. 5, the base 5 at the bottom is positive. We don't need to worry about that. So just let me rewrite that. Absolute value of x to the power of 2k plus 3 over 5 to the power of k minus 1. From basic algebra, you know that the kth root is the power of 1 over k, right? So I will have the limit as k tends to infinity. Absolute value of x to the power of 2k plus 3 over 5 over k minus 1, all to the power of 1 over k. Which means that the exponents of the numerator and the denominator should be multiplied by 1 over k. So let me rewrite this over here. So the limit as k tends to infinity, absolute value of x to the power of 2k plus 3 over k. At the bottom, 5 to the power of k minus 1 over k. So when k tends to infinity, you know how to deal with these limits. 2k plus 3 over k. What is the limit of that when k tends to infinity? You have seen this in sequences, and in general, these kind of limits you have discussed, you have seen in Calc 1. So the limit of 2k plus 3 over k when k tends to infinity, as you know, it's equal to 2. Even for the real valued function, the function of 2x plus 3 over x, the limit as x tends to infinity is going to be 2. So 2k plus 3 over k as k tends to infinity is 2. How about here? K minus 1 over k as k tends to infinity. Again, using the methods that you know from Calc 1, or we have seen similar things in this discussion of sequences. When k tends to infinity, k minus 1 over k is going to be, the limit is 1. So let's see what we have so far. The limit as k tends to infinity. From the top, we have absolute value of x to the power of 2. From the bottom, we have just 5. 5 to the power of 1 is just 5. It should be less than 1. There is no k remaining, so there is no need to the limit sign for k tending to infinity. So let me multiply both sides by 5. X squared is already positive, so there is no need to the absolute value sign. So x squared must be less than 5. This is an inequality that you have seen in basic algebra or more elementary courses. If x squared is less than a positive number, x is between radical of that positive number and minus radical of that positive number. So if x is in this interval, the power series is definitely convergent. So by solving this inequality, which guarantees that when we apply the root test, this is less than 1, we got this inequality, which has the solution of x more than minus radical 5 and less than radical 5. So for these x's, the power series is definitely convergent. For minus radical 5 and positive radical 5, it's not convergent because you can easily replace x by minus radical 5 or plus radical 5 and see that the general term of the series doesn't tend to 0, so it cannot be convergent. So the interval of convergence in this case is going to be from minus radical 5 to positive radical 5. So we use the root test and we got to this inequality and solved that. Again, the endpoints are not included because by replacing x by with minus radical 5 or plus radical 5, we don't get a convergent series. And what is radius of convergence? Radius of convergence R is going to be radical 5 because the center of that interval is 0 and the distance from 0 to the two endpoints, either minus radical 5 or positive radical 5, is equal to radical 5. So the radius of convergence is going to be equal to radical 5. So the part of the work that we had for this problem is here, and the other part is on the next slides. So with this work, we concluded that the interval of convergence is as we see here, and the radius of convergence is radical 5.